Hello viewers, welcome back to my channel. This is the second lesson on the video series on surds, and in this video lesson we are going to look at some important subsections or topics within surd. And these topics are not just relevant for solving questions in mathematics, but you also find them relevant in solving questions across various aspects of sciences. So I encourage you to get your writing materials and also watch this video lesson till the end. In the course of this video lesson, we are going to look at the following subtopics. We'll begin by looking at the simplification of surd. And in the course of this section, we are going to look at how we can make surd easier for calculation. And then we'll move on to look at how we can express surd in single form, in the sense that we'll make a surd to just be within the root and we have nothing outside the surd. And lastly, we are going to look at the addition and subtraction of unlike surd. Now, understanding how to simplify surd will make it easier, or will form the basis for us to add and subtract unlike surd. Because in our previous video lesson, that is the lesson 1, we said that we can only add surd that are the same. That means that for like surd, they can be added or subtracted But when they are different, we said that we cannot add them. But in the course of this video lesson, we are going to look at how we can do so even if they are not alike. So we begin this video lesson by looking at the simplification of surd. Now, what does this word simplification mean? Simplification actually means to simplify. Now, to simplify just means to make easy. So in this case, we are trying to look at how we can make surd easy to work on or to use them in calculation. It's just like having a raw food material or a raw meat, for example. You can't eat that meat until it goes through a process of simplification, which we can rightly call cooking. So that process of simplifying that raw food material to make it easier to use is what we call cooking in this case. And when it goes through cooking, the food becomes edible. So after cooking that meat with all the ingredients and spices, you can therefore consume that meat because now it is now in a form that you can use. So in the case of simplification of surd, we are trying to make surd easier for us to use. So it's just like having a very big surd. Let's say the square root of 1048, for example. Most students might find this difficult. Why? Because the number is very big. But when you make it simpler to use, it then becomes easier to work with. So in this case, it's just like we have root 32 plus root 16. When we see this surd, from our previous video lesson, we said that if surds are different, you cannot add them. So in real sense, my answer to this question will be root 32 plus root 16, because the surds are different, just like having one mango plus one orange. It is not possible for me to add them together and say 2 mango orange. So, such thing does not exist. So in this case, this does not exist. So in this case, my answer to this question will still be 1 mango plus 1 orange. So if you see surds that are different, you just simply write the question as an answer for them because you can't add them together. But after we have learned simplification of surd, we can now see how we can add these two surds or any surd we see. So moving on, we have root 32. We want to look at the rules for simplifying surds so that we can possibly add or subtract them. Now, what's the first rule? The first rule is that you are going to look for 2 factors. Now, recall 2 factors of that surd that you can multiply to get that surd, and one of them must be a perfect square. So there are 2 key terms I'm going to explain in this first rule. So when we talk about factors are just numbers that can divide another number. For example, let's say we have 6 for example. The factors of 6 are 1 because 1 can divide 6, 2, 3, and then 6. So these numbers that I just listed are the factors of 6. So these guys are the factors. But 8 is not a factor because you cannot divide 6 to get a whole number. Or if I have 12, for example, the factors of 12 will be 1, will be 2, will be 3, will be 4, will be 6, and will be 12. So all these numbers that I listed, 1, 2, 3, 4, 6, and 12, they are factors. 5, for example, is not a factor of any of the numbers because if you divide them, you won't get a whole number. So numbers that can divide another number to give you a whole number is what we call factors. So now we are going to look for two factors that we can multiply to give us this number, let's say 32 in this case, and one of them must be a perfect square. So now that takes us to the next aspect. What is a perfect square? So a perfect square is just simply a number that whenever you take the square root of that number, you always get a whole number. So whenever the square root of that number is taken, you definitely get a whole number. For example, 4 is a perfect square because when you take the square root of 4, you get 2. 9 is another perfect square because the square root of 9 is what? 3. Or let's say we have 25. 25 is what? 5. But if I tell you the square root of 2, for example, this will give you 1.414. So 2 is not a perfect square. So any number that we always give you a perfect square, we call them, or that will definitely give you a whole number, we call them perfect squares. So now for 32, there are several numbers that can give us 32. For example, 1 times 32 will give us 32. Or we can have 2 times 16 will give us 32. So we can also have others like 4 times 8 also give us 32. But we are going to work with the one that have the smallest number on one hand. So the smallest number in this case becomes this 2. So we are going to take this 2 times 16. So why are we also using 2 times 16? Because 16 here is a perfect square, because when you take the square root of 16, you get 4. So again, the rule is simple. Just find two numbers, any two numbers you can multiply to get that number, and you must find out that if one of them is a perfect square. So now we have gotten some factors. I'll write out the factors again. The factors can be 1 times 32. The factors can be 2 times 16. The factors can be 4 times 8. Now for this first one, 16 is a perfect square. So I can use that. 4 is a perfect square. You can also use this one, or you can use this one. But you can't use this one because none of them here is a perfect square. So this cannot work for us. But both of them, but I will always advise you, if you encounter something like this, pick the biggest perfect square, which is 16. So in this case, we are going to work with 2 times 16. So now I can replace 32. This is 32. I can replace 32 with the square root of 2 times 16. I've not changed anything because 2 times 16 will also give us 32. That's what will take us to our second point, which says replace the surd with the factors, which I've just done. Now the next thing I'm going to do is very simple. These are like brothers, and now they need their individual property 2. So in this case, I'm going to have root 2 times 16 to be the square root of 2 times the square root of 16. So each of them will take their respective square root, just like you are dividing a property within two brothers. So they'll take their respective square root. Now for the perfect square, you can take the square root in the sense that the square root of 16 is what? 4. So that becomes root 2 times 4, because we cannot, if we take the square root of 2, you won't get a whole number. So we are not going to go to that length. But we can take the square root of 16 to give us 4. Now, definitely, this is a whole number, and you are going to move the whole number to the front of the surd. So the final answer to this question becomes 4 root 2. So this is how we make a surd simpler. So moving on, there are other practice questions so that we can understand what we have just learned about simplification of surd. So we have root 16. So root 16 is very simple because this will always give us 4. So this is not a big deal. Now for the second question, which is square root of 27, two numbers that you can multiply to give you 27 will be 9 and 3, because if you check on your calculator, 9 times 3 will give you 27. Now again, give them their individual square root. So this becomes root 9 and this becomes root 3. Now the square root of 9 is what? 3. So final answer becomes 3 times root 3. But you can just simply join them together as what? 3 root 3. So we have simplified 27 to be 3 root 3. For the third question, we have the square root of 75. If you take your calculator and press square root of 75, you won't get a whole number. But we can make it simpler. So two numbers or two factors that we can multiply to give us 75 will be 25 times 3. Now again, you give them their individual roots. So this becomes 25 times root 3. And now the square root of 25 is 5. So final answer becomes 5 root 3. Now the same thing applies to the fourth question, which is square root of 125. Now two numbers we can also multiply to give us 125 will be 25 times 5. Now again we give them their individual roots. 25 will take its root and then 5 will also take its root. Now the square root of 25 is 5, so our final answer become 5 root 5. In this section of this video, we'll look at the expression of single surd. For us to understand the expression of single surd, we are going to look at this illustration. We have a student who leaves his house every day and walks to his school. Now, we expect that student at the end of the day to be able to leave his school and also walk back to his house because it's just a reverse of what the student did earlier. So in this case, the expression of single surd is just the opposite of the simplification of surd. So when I move from root 32 to 4 root 2, what I've simply done is that I have simplified. So this is a simplification process. So I've simplified that surd. So the reverse of this will be taking that simplified surd to a what? Single surd. So single because it is just root 32 within. But when it becomes simplified, I have something outside and I have something within the root. So the simplification of surd is just the opposite of the expression of single surds. So how do we express surd in single form? Now there are various steps we'll look at. Now we have 4 root 2. The first thing you have to do is to take the square of the whole number. The whole number is what we have outside. Now the square of it, which is 4 square, and 4 square will give us 16. So you are going to take the square of the number you have outside, and that is the whole number. The next thing I'm going to do is you are going to place that value that we got, which is 16 rather, in a square root. So this is square root. Then I'm going to place it within. So I'm going to place the 16 within the square root. Then the next thing I'm going to do is to multiply both surds. And what are the both surds? This root 16 that we derive and root 2 we had initially. So I'm going to have it as square root of 16 times the square root of 2. So I'm going to multiply them. And remember our rule for multiplication. For multiplication, you can always multiply them if they are similar or if they are different. So I'm going to take a single root and then I'm going to have 16 times 2. And 16 times 2 will give us 32. So in this case, root 32 is our final answer. So in this case, I'll be able to carry this root from the simplified form to a single surd. In this section of this video lesson, we are going to look at the addition and subtraction of surd. Now, the various rules and knowledge we have on the simplification of surd, which we looked at in the first part of this video lesson, will help us to add and subtract surd, irrespective of the fact if they are alike or they are not alike. Now recall that in the previous video lesson, which is lesson 1, we said that for like surds, we can add and also subtract them. So when they are alike, we can add and also we can also subtract them. But for unlike surd, we cannot add or subtract them. So for these guys, their addition and their subtraction is not possible. So for like surd, we can add and also subtract them together. But for unlike surd, it is not possible to add or subtract them together. But we can attempt simplifying these surds, and sometimes after simplifying them, they might not look alike. So now let's come down to this question. So we have the square root of 27. So let's simplify the square root of 27. Now two numbers we can multiply to give us 27 will be 9 and 3. So this is 9 times 3. So then the next is square root of 12. And two numbers can multiply to give us 12 be 4 times 3. Recall that 1 must be a perfect square. Now for 75, two numbers we can multiply will be 25 times 3. So now the square root of 9 is 3. So this becomes 3 root 3. So we can find the square root of this one. So it's going to remain within the root. Plus the square root of 4 here is 2. So this is going to be 2. Root 3 will still remain within the root. Then minus the square root of 25 is 5 root 3. So now looking at this is root 3, this is root 3, and then this is root 3. You now find out that the surds are not the same. Why? Because we have simplified them. So because they are the same, we cannot add and subtract them. So we've moved this surd from this unlike form to this like forms. So now we now have 3 So on the outer part, we have 3 plus 2 minus 5. So then root 3. So then root 3 is outside. So 3 plus 2 is 5. Then 5 minus 5 is 0. So we have 0 root 3. I know anything times 0 is what? 0. So just like saying 3 here 2, that's 5. Then 5 minus 5 here will give us 0. And 0 times root 3 is 0. So this is how we can make sorts similar, and then we can now add them or subtract them. So the second question is root 50 plus root 27 minus root 32 plus root 75. Now looking at this question, 50, 27, 32, and 75 are all different numbers in the sense that they are different from one another. So what can we do? With our knowledge on simplification, we can simplify this sum and see if some are similar for us to either add or subtract. So let's go. Now, two numbers again, you can multiply to give 50, such that one is a perfect square will be 25 times 2, because 25 is a perfect square. Then for root 27, two numbers we can get should be 9 times 3. Then for 32, two numbers we can multiply rather should be 16 times 2. Then lastly, for root 25, two numbers we can multiply will be 25 times 3. Now, if you look at my arrangement, I like writing the perfect square at the beginning. For example, root 25, 9, 16, and 25. I like writing them at the beginning. Now, the square root of 25 is 5, right? So this will be 5 root 2 plus the square root of 9 is 3. This will be 3 root 3 minus the square root of 16 is 4. So that will be 4 root 2. Lastly, the square root of 25 is 5. So that will be 5 root 3. Now, if we take a look at these answers, the square root of 2 here will be similar to the square root of 2 here. Then the square root of 3 will be similar to the square root of 3. So I'm going to pair them. So this is 5 root 2. So I'm going to take the other one that has a 2, that's minus 4 root 2 closer. Then the next is 3 root 3 plus 3 root 3 plus 5 root 3. So now root 2 and root 2 are similar, so I can subtract them. Now 5 minus 4 is 1, so it just becomes root 2. There's no need to write the 1. There's an invisible 1 here, but it's more okay or appropriate. Just write root 2. Then for 3 plus 5, because this one they are similar, root 3 and root 3. So 3 plus 5 is 8 root 3. So finally, our final answer becomes root 2 plus 8 root 3. So in the last question, we have the square root of 50 plus the square root of 75 minus the square root of 98. So the square root of 50 can be written as the square root of 25 times 2. Recall that you are going to find two numbers such that one must be a perfect square. Now for the square root of 75, we can write it as 25 times 3. And then for the square root of 98, you can write it as 49 times 2. So now we have this. Now the square root of 25 is 5. So this becomes 5 root 2 plus the square root of 25 again is also 5. That becomes 5 root 3. Now minus the square root of 49 is 7. So this becomes 7 root 2. Now if you look at this is root 2. And then this at this other end is also root 2. So they are similar. So I can rearrange this to be 5 root 2 minus 7 root 2 plus 5 root 3. So now 5 outside minus 7 here is minus 2. 5 minus 7 is minus 2 root 2. Then on that hand, we have 5 root 3. So this is the answer to this question. Or some person may write it as 5 root 3 minus 2 root 2. So they'll just rearrange what we have here. Take this outside and then bring this inside. So any of them is the answer to the question. So viewers, I hope you enjoyed this video lesson and you learned something from this video lesson. Don't forget to give this video lesson a thumbs up, and also don't forget to share this video lesson with your friends so that we can all learn together. And if you have any question, comment or suggestion, don't forget to leave them in the comment section beneath this video lesson. And if you are new here and you haven't subscribed to this channel, don't forget to click on the subscription icon just beneath the video lesson so that you always get notified whenever I release any new video. So till you get to see my next video, do have a wonderful time.